Okay, fantastic. Right. So we're starting on time at 12:30, so UK time. So thank you very much for all joining us for today's webinar from the IMechE. Today's one is 8D, PDCA and DMAIC. What's the difference and why does it matter? So before we get cracking on to this webinar today, just a few introductions. My name is Dan Sanders, and I'm the moderator for today's session. I work for the L&D team at the IMechE, and as well as providing these type of webinars on a monthly basis, we also do provide a number of other training programs and courses that we can run for both individuals and on site within companies. And of course, as we do, we run both our programs and courses in a virtual or face-to-face setting. I will be keeping updated with a number of web links to our particular courses that we actually going to be running, including from the one today. Today is just a sort of bit of an appetite to the actual course itself. So if you are interested, I'll be sending you information throughout the session today into the chat box itself. So just a couple of housekeeping points before we kick off. If any of you do experience any technical difficulties, please do let us know in the actual chat box, and one of our team will be instantly onto you and be able to support you and directly message you to see if they can support that. Today's session is actually also quite interactive. There will be some time for Q&A at the end, but also we're going to be running a couple of polls throughout today's session, which is going to be interesting to see. So please, if you can interact with us and answer the questions that are in the polls during the session, that would be really helpful. And we're going to provide the kind of feedback to the results that we get from this as well. So from the Q&A session, as I said, there'll be some time at the end, but all the way throughout the session, I'll be collating the questions so that I can field them back to the presenter at the end. So if there's something that's been discussed you wanted to bring into conversation, please do feel free to put that into the chat box. Okay, right, without further ado, let me bring into you our presenter. We're very, very fortunate and happy to have Mike O'Connell today, who's joining us. He has been involved in continuous improvement and problem solving for over 20 years. He's certified as a Master Black Belt while being at Johnson & Johnson, and then has been really in a fortunate enough position to deliver training across a varied amount of industries, such as the surgical and medical, sports car manufacturing, through to food labelling and national transportation. So we're really fortunate to have Mike here with us today. I will now pass you over to Mike.
Dan, thank you very much indeed for the introduction, and it's great to have the opportunity to talk to you all today about 8D, PDCA and DMAIC. What's the difference and why does it matter? And as Dan said, I've been lucky enough to see very good problem solving and continuous improvement in many different industries. The one place I've found that it's failed utterly is trying to improve the process of my children leaving the house in the morning. That seems to resist any improvement process at all. So hopefully today we'll focus on more achievable aims than that one. So let's have a little look at what we're going to cover today in terms of the agenda. So I'd like to give you a little bit of a background to problem solving, sort of the things that underpin it and some of the themes. We'll take a look at each of these different techniques of 8D, PDCA and DMAIC, talk a little bit about what the steps are for each of them and what's involved, what's similar and what's different, and then how do you pick the right approach and make it work in your organization. And as Dan said, we'll build in some time for questions at the end, but also if there are questions through the session that Dan will feed to me, I will do my best to answer those. So I'd like to take a little sort of step back into the history of problem solving here. I'd like to take you to a little town in Germany called Schöningen. It's in Lower Saxony. It's about halfway between Hanover and Berlin. And between about 1994 and 1998, there was quite a big archaeological dig going on there under the watchful guidance of Hartmut Thieme. And one of the things that they uncovered were 8 spears. 7 of them were made of spruce, and 1 of them was made of pine. They're about 2 meters long. And their design is really very similar to a modern javelin, in that the weight is mostly in the front third of the spear. So they're very well designed to be aerodynamic. And what they've discovered is that using modern athletes, that these spears can be thrown about 200 feet. So quite remarkable. But probably the most remarkable thing about them is where they discovered them in this open cast coal mine. The sedimentary rock that they were between means that they are over 300,000 years old. Now, what that means is that these spears were created by precursors to Neanderthals. Now, you might be thinking, what on earth does this have to do with modern problem solving? And I'm fairly sure they didn't use 8D, PDCA, or DMAIC to do this. And I'd agree with you. But I tell this story for 2 reasons. One is that, as a species, we've been problem solving for a long time. And the second is that when I first read about this, I realized that my assumptions of Neanderthals and their precursors was actually quite wrong. I had them as sort of slow and lumbering and all brawn and no brain. And the Schöningen spears suggest something different, that they were able enough to create these quite highly crafted artifacts and socially adept enough to be able to use them in a coherent manner. So my assumptions were probably all wrong there. And our assumptions when we go into problem-solving activities can sometimes be really helpful to us because they allow us to bridge gaps and solve problems. But sometimes they can send us down the wrong path. So we need to be aware of both. And when we talk about problem solving, when we talk about problems, I mean it in quite a broad context. So what I mean is that there's some sort of gap has occurred. Now, Art Smalley talks about 4 different kinds of problems. I'm a simple sort of person, so I'm going to reduce it just to 2. I think there's the type of problem which I call the floor drops away. And that's where you're walking along, everything seems fine, and then something happens. Something goes wrong. The ground drops away from under you. You find yourself in the basement, and you're trying to work out, how do I get back to where I was? This machine was running perfectly. Suddenly, it's producing lots of defects. What happened? What was the root cause? So that's the first kind. The second kind, I call the roof flies away. And that's a bit different. That's where you're walking along, and nothing's really changed, but suddenly you look up and you realize there's an opportunity here. There's an opportunity to make things better that I didn't realize before. And yet again, a gap has appeared between where we are and where we could be, but it's appeared in a slightly different way. But in both those cases, problem solving is about how do we bridge that gap. And I'm going to talk about these techniques, some of which apply maybe a bit better to that first kind of problem, and others which you could use on that sort of second kind of problem. Now, before I go into the sort of mechanics of each of the approaches here, I just wanted to sort of think about some of the themes that underpin problem solving. And like many people this year, during the various lockdowns and everything else that's happened, I've found myself at home with children who are at home needing to be schooled and entertained, so with a little more of that to do than would normally be the case. And what I have discovered is that that puzzles were a good thing to fill that space. And I'm sorry, Dan, my slides have disappeared from here, so I'm not sure whether they're showing through the webinar. Okay.
Yes, Mike, they are. We can see the picture with the puzzle pieces on there at the moment.
Okay, that's fine. If you can see, that's great. It's not showing in my window. It's just showing blank as webinar. So I will hope that that's come through. Okay. We started to discover jigsaw puzzles. And as we were doing these jigsaw puzzles, I was idly thinking about preparing for this presentation. And I realized that some of the things we were doing there were actually some things that you do when you are solving problems. So I don't know if there's anybody in the audience who's got into puzzles recently by the sales of them during the last year or so. I think they've become much more popular. But you may think, what's the first thing you do when you do a jigsaw puzzle? Well, the first thing that we do is separate out all of the edge pieces. So you find all of the pieces from the edge of the puzzle and you put them in a pile. And I know other people separate things out by color or by shape. And so we have a process. We follow a process. And when we're thinking about problem solving, following a process is often a really useful thing to do. And we'll see that in all three techniques that we talk about today. Now, the other thing that can happen is that we can have too much information or too little information. And this image on the left, this is a genuine jigsaw puzzle. If there's anybody you really don't like, this is a puzzle you could get for them because it's a horrible one to do. And what it has is too much information. It makes it really hard to see what's going on. And nowadays, we have a lot of data sometimes, but sometimes not much insight because we're almost swamped by it. So that can be one problem. And sometimes we don't have enough information. One of the other things I noticed was when I picked up a piece of a puzzle, I would often stare at it for quite some time, trying to work out what was going on. And then I would realize I needed to turn it upside down. And often when we're problem solving, we get given some information and we look at it in a certain context. And it's not until we switch our view or our angle that we see where it fits, that it much more easily fits somewhere. So some other things that I noticed that were sort of similar as well in terms of themes. So fixating on one problem, you can miss the big picture. So you spend so much time trying to fix one thing, you forget there's a lot of other things that need to happen. And if I know what somebody else is trying to do, I can help them by passing them the right pieces of the puzzle. So having a team and understanding what's going on around you can also be really useful. But unlike jigsaw puzzles, the real world problems that we're trying to fix sometimes have many solutions, sometimes have no practical solution. So in that respect, they're a little different. But one thing I really did notice was that human error occurs a lot. And so we would always take the center pieces out of the puzzle and try to put them to one side. And we've done lots of jigsaw puzzles, and not once yet have we managed to separate successfully all the edge pieces. We always leave some in the box. I think it's probably me who does it. So people make mistakes. Human errors occur. When we're dealing with systems and processes that involve people doing things, that happens. not because people are lazy, not because they're not paying attention or they're not careful, but because our concentration doesn't work that way. And the last thing I realized was that actually, how good does something need to be? And anybody who's done a 2,000-piece puzzle knows that if you end up with 1,999 pieces at the end, that is not good enough. So sometimes we need to be better than that, but sometimes we don't. So what level is good enough when it comes to our problem solving? Now, let's take a look at some of the detail behind these different roadmaps to problem solving. So what I'd like to do is just a little poll of the audience, and we're going to try and do this and collect some information from you. So in terms of 8D, PDCA, and DMAIC, which ones of those have you used? So hopefully a poll will open up and you'll get the opportunity to answer, and we'll collect the results and take a look at them. So Dan, I'm not sure if we're getting some information back from that. We can maybe take a look at. Otherwise, I'll move through.
No, nothing's come through yet.
Okay,
I understand. Yeah, it's just come through. Okay, I've got the results here. It's pretty evenly spread, Mike. Actually. 31.5% it's 8D. I've used 8D. 23.7% DMAIC. PDCA is 21%, and other is the 23.5%. So it's very evenly spread, that.
Excellent, excellent. Thank you. So what that means is I've got no easy pass here, that you're all familiar with all of these techniques, so you can ask me difficult questions about any of them. So that's excellent. Interesting to see that it is quite an even mix. Excellent, thank you. So let's take a look at each one of these in turn. And I appreciate that some of you may be very familiar with these techniques and use them a lot. And I'm going to look at sort of some of the similarities and differences across all of them. So we're going to do this at sort of quite a high level. Okay, so 8D as a technique. So 8D, a little bit of the history of that. It was developed really in the automotive industry back in the 80s based on a military standard. If you take a look at that military standard, it's to do with non-conformances. It doesn't really jump out and scream 8D to me when I look at it, but I could see how it would be the inspiration for the 8D process. But the one that we really talk about here is the one that came from the automotive industry. So it's a 9-step process. 8D, 8 disciplines, it's got 9 steps, so we've snuck an extra one in there. So we have this D0, which is a planning step, where we might collect information, check what symptoms are happening, understand if we need to sort of put an emergency response in place, and really get a feel for what is the target of what we're trying to fix here. Once we've done that, we can establish a cross-functional team, and they can then describe the problem in as much detail as possible. So put in problem statements, 5 whys, observing what's happening, what isn't happening. One of the things that's sort of quite specific to the 8D process is the containment measures. So that's about trying to protect the customer or the end user from whatever this issue is. So can we put some temporary things in place that allow us to minimize that effect? At the same time, we can be thinking about identifying and verifying the root causes. So if we can really get to the root cause, we can turn the problem on and off again. And once we've done that, we can look at what's the best solutions. What permanent corrections will best address those root causes. And then we can implement them, put them in place, but also think about preventative measures. So what do we need to do in terms of systems, behaviors, and people to reduce the risk of the problem recurring? And at the end of all this, we want to congratulate the team, because it's important to do that and to share the learning as well. So let me show you an example of that. This is a sort of fictionalized example, if you like. It's based on real events, but they've been sort of fictionalized a little bit here. So this is what a typical 8D might look like. I appreciate there's a lot of words on this slide, so let me pick out some key points. So we've got a customer complaint for damage, which has increased recently. We're in a biscuit manufacturing environment here, making their mustard cream biscuits, which don't sound particularly nice, but there we are. So they've increased complaints by 45%, which equates to just 121 a month, but that's quite a few for this company. It costs them £72,000 a year and reputational costs. So this is quite a big issue for this company. So we know a little bit about sort of the plan and established the team and described the problem. They put some containment measures in place, which was to put some extra inspection in place, and also a bit of packaging, increasing the packaging to help with transportation, which has cost associated with it, but hopefully it's worth it for a temporary measure and we won't need it there too long. The team then do some work, they dig into this, they use fault tree analysis, they review all the production data, create some process maps, some timelines and things like that, and they find two potential things that could be the cause here: a change in the grade of the rubber or an increase in the bake temperature. So they do some experimentation. They find out what's happened and that it is down to the change in the grade of rubber in the machine handling. So they update, they reverse that change, and they update the specification on the machine to put something in place to try and make sure that doesn't happen again, because we had something there that was a bit uncontrolled. And then the team are rewarded. They get a lifetime supply of mustard creams. That probably means about 1 packet, and the learning is shared across everybody. So that's an example of 8D. Let's have a look now at PDCA. So this is the Plan, Do, Check, Act. It has an interesting history, and it's quite involved. And it goes back to Schuhart and Deming back in the early part of the 1900s. And in the 1950s, Deming was giving lectures in Japan. And it was from those lectures and some of the ideas he introduced there that the Plan, Do, Check, Act really evolved. It's a little bit sometimes confused with the PDCA and some of the things Deming developed after that, but I'm really talking about it here in terms of the Plan, Do, Check, Act that was developed in Japan at that time. So what we're talking about is, well, a 4-step process. You plan a change, define what you expect to do and what's going to happen, and then we have to test out that hypothesis. So we try running the process according to the plan and sort of measure what happens, and then we study the results and we see, do the results give me what I expected? And based on that, I can then either standardize what works, or I can go through and see from what I've learned, what can I do next? And I can keep going through that process. So let's have a look at a similar example of what that might look like in the real world. So this was an example where we were looking at reducing changeover times for a label press. And you discover that the changeover time, it's currently 45 minutes with quite a big range, 15 minutes up to 30 minutes here. And the team believe that it could be as little as 20 minutes. So they break down the process into the steps, and they look at the timings for each step and identify a number of areas where the problems occur and think that those are areas that they can target. They run a trial, measure and observe what happens. And they find the changeover time is 18 minutes. And the gains mainly happened in the areas where we thought there was a problem. So what they're then able to do is roll that out across all 4 shifts, and they find that it works well on 3 of the shifts, but for 1, there's actually an issue. So they've almost got to go through this cycle again and understand what's happened there. What can you study? What can you learn from studying that result? And they find that the limitation of access to gauges for the night shift was the problem, and they can fix that issue. At the end of all this, the team believe that they can reduce this even further down to 12 minutes, and then the cycle starts once more. The last technique is the DMAIC methodology. So the DMAIC methodology was developed at Motorola back in the 80s. For those of you who don't know what that is in this picture, that's what telephones used to look like. And in those days, if you ever had to dial 0, it was a real pain because you had to wait a long time for it to go back to the home position. Not a problem we have these days. So this is the DMAIC problem-solving approach, a 5-step problem-solving and continuous improvement to do with reducing variation, limiting us to 3.4 defects per million opportunities. That's what DMAIC was about in the beginning, but it's not really totally focused on that. It's about what's the right level of quality that you need to get to. Define is what's the problem and who cares. Measure is how big is the problem and are you measuring it properly. Analyze what are the root causes, and improve, finding the fixes that best address those, and then control is making sure that they stay fixed. So let's have a look at an example of a DMAIC improvement process. In this example, we have parts failing a dimensional specification. And it's costing about £247,000 a year in extra scrap here. It's gone up from a level of 1.8% to 2.9%. So we sort of know what the problem is. We know how big it is. I can identify some root causes using things like fishbone diagrams and, again, process flow mapping, timelines, some experimentation. And in this particular example, it was found that the dryer speed was the issue, and that the dryer speed had been changed as part of an improvement efficiency project because it saved £32,000 a year. So in this particular example, that change was reversed. And now there's an improvement opportunity here to think about, well, why did that happen in the first place? And it's one of the interesting things for problem solving is that when we fix one problem, we can sometimes introduce errors somewhere else. So we have to think about sort of systems and how things link together. I think of it as a little bit like gravity. The bigger the change and the closer you are to it, the more likely you are to have an effect on something else. So we always want to consider that element of things. So what are the similarities and differences between these approaches? Because I think what you can see is that from the examples that I've given, that there are actually a lot of similarities between all of them. In fact, the examples really could almost fit into any one of those three, because they all require you to have a really well-defined problem. And the better the problem definition, the more likely it is that we will get to a good solution. They all require you to have measured something. We have to collect some information. And if we're thinking about measurement, we need to think about how good is our measurement system? Can we trust the data? Is it reliable? Is it accurate? Is it repeatable? Is it reproducible? All those things are important. And the other thing that they all require us to do is to take some action. Because if you don't change anything, nothing's going to happen. So we have to do experimentation. We have to see what happens and observe the effects. You know, if nothing changes, nothing changes. So, and knowledge doesn't change things, but application of knowledge changes things. So we need to try and apply these things to see what happens. And if you look at the tools and techniques that underpin all of these different approaches, what you'll see is that there's actually a lot of similarity in the tools and techniques, but there are some differences as well. So what this table is meant to show is really just the particular tools that these methodologies often call out. So if you look at things like 8D and DMAIC, we'll often explicitly mention things like measurement system analysis or 5 whys or cause and effect. So we can be quite prescriptive in terms of what tools might help us solve the problems. PDCA is a little bit different in that it's more of a framework that you can attach these tools to, but it doesn't really prescribe them so much. It's a bit more open-ended that way. Now, when you're thinking about what's right for your organization, sometimes you might want a situation where people are told, these are the tools that you should use, and you should pick this one, and there's some standardization there. But there are other times where we really want people to make up their own mind, because we can't know what all the problems are going to be that we're trying to overcome. So having that flexibility to pick the right things, I think, is really important. Now, all of these tools and techniques, they require us to use good data and to use data well. So one thing to think about is, where does that data come from? So I'd like to collect a little more information here. So I've got an example here of some data, and hopefully you can see the picture here of an airplane. So during World War II, the American military were looking at the location of bullet holes on returning bomber planes. So they were trying to work out, where's the greatest density of these? So where are the places that you need to put extra armor to make the plane have a better chance against the enemy fire? So what I'd like you to think about, there's 5 different locations, hopefully you can see on that image, A, B, C, D, and E. So we'll just open up a little poll here just to allow you to select, if this were you, where would you place that extra armor to have the greatest effect? Excellent. So hopefully, I think, Dan, that hopefully we'll get some information back again this time.
Yeah, just waiting. I think we've got it now. Okay.
Excellent.
So the top answer was position C, where 41%.
Position C.
Yeah, 41% people there, and then second was position E.
But excellent. Okay, good. So I think when I first looked at this, I probably picked position C as well. So the area where there's greatest density seems to make sense, doesn't it? Now, for those who picked position E, you might have been very, very cunning there. So what one of the statisticians, a guy called Abraham Vold, he noted that, well, the data that you're seeing there is only from the aircraft that make it back. So what you're not seeing is the ones that didn't come back. And what you see on those pictures is there's some areas where you don't see many bullet holes. And the reason for that, he surmised, was that actually if you get hit in those areas, the plane doesn't make it back. So where you want to put your extra armor is actually those locations where you're seeing missing values, because that tells you that those are the most important locations to protect. So it's an interesting example of where we have where what the data isn't showing us, the missing data, is actually more valuable than the data that we see. And it's something we need to think about when we're problem solving. And all of these techniques allow us to consider that, but we have to actively think about that as we're using them, because it's very easy to become so fixated on what we're actually seeing that we miss some of those things that go around it. Okay, so what about the differences in terms of these techniques, and why is that important? Well, I think, in many ways the differences are probably few and far between, but I think there are some specific things that make some of these techniques better in certain circumstances. So one thing to think about, particularly with the 8D, is it's very well focused on dealing with non-conformances and complaints and problems that are triggered by that sort of thing happening, because that's what it was designed to do. And the implementing countermeasures is a really good step in there that's not really called out in the other two techniques. So I think it fits very well in that particular scenario. Measurement system analysis is only really called out explicitly in DMAIC, but I would never run a problem-solving workshop on 8D or PDCA without thinking about the measurement system and how I collect and how the data is collected. So although it's not called out in the others, it's still important to them. Some people say that depending on the scale of the problem, one fits better than another. PDCA probably works quite well where you have lots and lots of small iterations that you want to make to fix a problem. But actually, they do all scale to a certain extent. So I think you can probably use all of them that way. So many similarities between them, many similarities. And actually, what's maybe more important than the differences is picking the right approach that will work for your organization. If I'm talking to a company and they say, we really don't like DMAIC and Six Sigma, it doesn't work very well at all. It's an outdated approach and it's no good. And I said, okay, what about 8D? How do you feel about 8D? Oh, we love 8D. 8D, we've got some people from automotive, they really like 8D. So great, let's use 8D. Because if people accept the approach and they buy into it, and you will get much better results than if they don't. So we need both the managers and the people who are using the tools and techniques to buy into them. And that's far more important. So having knowledge of the tools and techniques is useful, but having that acceptance is really quite critical. And I do quite a lot of, I'm based in the north of Scotland. I do quite a lot of hill walking, or at least I used to do quite a lot of hill walking. This is a hill in Torridon called Ben Alligan. And one of the things you notice when you walk on the hills is that paths appear because people tread the same route every time. So we follow the same route and the paths appear and get worn down that way. And in some ways, our brains work in a similar way. And Admiral Grace Hopper, one of the pioneers of computer science, said the most dangerous phrase in the language is, "We've always done it this way." So when we pick any of these techniques, it's really important to give people the space to come up with innovative solutions to problems and not be too shackled by the way that we've done it in the past. So I would suggest that you pick one and make it work. 8D does have a good solid framework, and it's a logical one to follow. But particularly if you're needing to consider NCs and complaints and where countermeasures are important, then it's a key one. So as Dan mentioned, there will be an 8D workshop that's running where we'll really get into using it in anger in terms of both understanding it as a technique, but also how do you make it stick in your organization. And it'll be very interactive. and engaging. So if it's something that you think is of value to you, the information will be there for you to sign up to that. Okay. Okay. So, in summary, the same problem-solving impulse that allowed our early ancestors to create spears that they flew 200 feet has now seen us land a vehicle on Mars, 200 million kilometers away. So sometimes we have to tackle big problems. Sometimes we do need to tackle the big problems. But if you pick enough of the small problems and you tackle those and you do it in the right way and they all link together, then what you can end up with is a picture that's a lot more impressive than the sort of sum of the individual parts. So what I hope is that you have good success in using problem-solving techniques, and who knows, that maybe you'll solve a problem that people will still be talking about 300,000 years from now. So thank you very much for giving me the opportunity to speak to you. I wanted to leave plenty of time for questions, so Dan, I'll pass it back to you in case there are questions that we can take.
Okay, so yeah, thanks very much, Mike. Yeah, a fascinating subject there, and very, very, very interesting that. So thank you for that. So yeah, some questions have been coming in. So one of the ones came from Adam Hughes early on, actually. He says, is PDCA the same as RCCA or RRCA?
RCCA, I don't know the answer to that, but I will certainly find that out, and we can put that into the answer pack. What I do know is there is a PDSA, which Dr. Deming came up with, which he always maintained was a very different thing from PDCA. So it does have an interesting history that way, but let me try and get a good answer to that one.
Okay, fantastic. Another one came in from Jonathan Holmes. His question was, do you see FMEA fitting as a method for problem solving or something separate to problem solving?
FMEA is an interesting technique because my experience of it is that often it fills people with dread, or that it just becomes a scoring exercise that you have to go through for a regulatory reason and things like that. But I think it can be a really effective tool within problem solving. It sits in there as a way to think about implementing solutions and prioritization of things. So I think it is a very effective tool. But sometimes we can get a little bit bogged down using it. So if you use it the right way, I think it can be really helpful.
Okay. And another one here from Chris Roberts. What about methods of problem solving that heavily involve people and human factors?
So when you're dealing with people and human factors, it becomes complex because people behave differently from machines, but some of the principles work the same. So if you can think about things like mistake proofing and building into designs early on features that work in a particular way, then you can sort of overcome some of those issues. And what it sometimes comes down to is whether you're doing, I spoke in the beginning about sort of problems where you're trying to find root cause, sort of ground has dropped away. And those problems, sometimes you may be able to get around those entirely by coming up with something innovative. So sometimes we have to step back and say, do I really need to fix this problem as it exists, or could I do something completely different here? And sometimes when it's sort of people-based or human factors, there's the opportunity to do some of those kind of things.
Or just to let you know, Mike's getting some fantastic feedback in the chat box. Brilliant presentation. Some of them have said, "Are you going to be running this again?" Or something similar. So literally everyone's saying very, very, very positive about the session this afternoon.
So that may be my dad who's logged in or something like that.
Another one here from Daniel Brown. He's asked, what's the link between 8D, PDCA, DMAIC, and Six Sigma?
So Six Sigma is what Motorola call DMAIC. Motorola coined it as Six Sigma, and Six Sigma was 3.4 defects per million opportunities is a Six Sigma process. And in order to get to that, you could follow the DMAIC roadmap to get you there. So the DMAIC is the process that gets you there. But really, sometimes people become a bit fixated on that 3.4 defects per million opportunities. And they use it as a criticism of Six Sigma and say that's not good enough for some processes. If I'm making a component that has a million sort of parts to it, like a very complicated component, then if it's got 3.4 defects, each one will be a failure. So absolutely. So you need a better level of quality than that for something like that. So it's not about getting fixated on that number, but that's sort of where the linkage is.
Okay. How big or cross-functional should the group be for 8D meetings?
That's probably a little bit of a judgment call depending on the problem. Mm-hmm. My experience is that as soon as you make the groups too big, then things grind to a halt. But you also want to try and have the right blend of people in there. So it'll depend on your organization. It'll depend on the size of the problem that you're trying to fix. You may also think about not having all of those people involved all the way through. Maybe it's one group of people who are defining the problem, but it may be that there's different people who are coming up with the solutions because you need a slightly different skill set. So it doesn't need to be the same team necessarily from start to finish, again, depending on what the size and scope of it is.
Okay. Some great questions coming in, and everyone's just saying excellent presentation. It's fantastic to see here, Mike.
Thank you.
One of the ones from Ravinder Dosanjh. Which of these, bit of a challenging one here, which of these three methods have you, the expert, personally used or found to be the most effective generally?
Well, I've used them all. My background is probably meant I've used Six Sigma a little bit more for a longer time because that's where I was initially trained, was in Six Sigma. But I've found them all useful, and to be honest, I find them quite interchangeable. Some of the tools are very interchangeable between all of them as well. So the sort of underpinning philosophies are similar across all three. But I'm not because this is an 8D one. The 8D is excellent, but they all have their place and they all have their value.
Okay. Can this is a question from Sohail Kashul. Can 8D and PDCA combine and be implemented?
So I've seen PDCA certainly used within some of the other techniques as well, often at the sort of implementation stage. So yes, I think they can. I think they can link together a little bit that way.
Okay. So again, excellent presentation. What would be your best tip? This is from Miguel Gonzalez. What would be your best tip to push these problem-solving practices to an extended segment of an organization?
So you need people to buy in. You need people to buy in. And what I would say is for all of these, get close to where people are going to use them, understand the problems that they're trying to deal with, and help them see what the value is. Because if people, particularly when they're working in, challenging jobs to begin with, if you give them another bunch of stuff that they have to do, then it can feel like, how is this helping me? So if you can show people how it's helping them, and what they'll get from it, they're much more likely to sort of embrace it and use it. So, if you can pick some maybe some areas where you think there's a good chance of getting some early successes, that can always help. But really getting close to the processes, walking the problems and seeing firsthand what's happening is much more valuable than sort of doing this stuff from a distance far away.
Okay. Thank you, Mike. Yeah, the questions keep coming in. So are you okay to answer a few more, Mike?
Yes, by all means.
So this one's from Sean Duggan. He says, you mentioned earlier that the quality of the data, the measurements, is important. He says, most projects I've been involved with struggles to find the data quickly. Any sort of tips, particularly when the process seems long and drawn out?
So, I mean, it can be, and sometimes the whole thing can fall apart because you don't have access to the data that you need. In terms of tips, I suppose a little bit of time on the data collection planning up front is sometimes time well spent. So, if you can build things in early, then that's great. Understanding the limitations of the data you have. So we never have perfect sets of data and we never have complete sets of data. But at least if we can understand their limitations, we can sort of make some progress understanding that limitation, see what happens, maybe do some experimentation. And, sometimes you just have to put the historical data to one side and say, look, it's too messy, it's too difficult to get to. I need to just try and collect a small amount of good quality data that I can rely on and build something from there. So that can also be an approach that works.
Okay, and someone here from Liam Kenyon, his question is, what is your general experience in implementing problem-solving tools within an organization? What, in your opinion, is the best kind of approach to this?
So it's a real mix. You find that some places there's a lot of resistance depending on what the history is, and other places they're really keen to embrace things. So, it's about understanding your organization and that side of things. And sometimes I think what we do is we copy what other organizations do and say, look, we're using the same tools as Toyota. We're using the same tools as somebody else. And that's okay. But they were using them at that time because it fitted really well with the culture and what people were doing. So it's about understanding what's the right thing for your organization at that time, and not necessarily just copying what other people do because, their situation might be somewhat different. So I'm sorry, that was probably quite a broad answer. So I'm not sure if that was specific enough, Dan, but...
No, it's fantastic. No, that's brilliant. Okay, well, I think there are many other questions, and I think what we will do is we'll collate all these questions and we'll put them onto a document, and it will be made readily available for people after this session, should there be anything that was missed. Maybe shall I do one more question for you? Oh, they just keep coming in. We could be here for a long time. You've really got people talking here. What kind of problem solving do you recommend to substantiate or drive, in brackets, engineering design change?
So that's the sort of engineering design changes. So I wonder if that relates to sort of early in a design process, or whether we're talking about changing a design because something's gone wrong. So I'll maybe sort of separate those out a little bit. I suppose if it's early in a design process, we can be a bit more sometimes innovative in how we think and how we approach our problem solving, because we might not necessarily be looking for root cause there. We might be looking for what's a better way of doing this that doesn't currently exist at the moment. So while you can use DMAIC and things like that for that, you might be using a slightly different approach, more like an innovation type approach, sort of system design and those kind of things. If you're looking at an engineering solution because something's gone wrong, then I think all of these approaches that we talked about today would apply for that, and you could use them in that environment.
Fantastic, thank you, Mike. Okay, But just to let you know, I mean, are we, on the slides there, you can see, I think, all these questions that are coming out, obviously, if people want to go into a little more depth into the FMEA, into the 8D problem solving and into TRIZ, then we've got the courses coming up that you can see on the slides there. Please take a look on the link to the website there if you would like to sign on individually and attend one of these courses. Obviously, the reaction I can see from the chat that there is a lot of questions around this, and I think, when you attend one of these courses, these sort of questions will no doubt get answered. So, please do take a look into those for the future. But other than that, I think but thank you very much, Mike, and thank you very much for coming along and delivering an excellent session. Great feedback. The feedback's fantastic. We've seen from the attendee chat, and already they're asking for another session like this, Mike. So you've done something right, definitely.
Excellent. Thank you, Dan. Really appreciate the opportunity to talk to people today. So thank you.
Okay, and just a reminder, what we will do is the answers to the FAQs will be available once you signed up and then downloaded onto your LMS and have access to the webinar schedule and the documentation to all the answers to these questions. So they will be readily available if you sign yourself in to the IMechE's LMS system for this. But thank you very much for everyone joining us this afternoon. Thank you.